Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers in an online format, join our lectures. You can find the link to our Discord in our Telegram channel. Today, we will talk about quicksort and start with its definition. Quicksort is a sorting algorithm that works on the principle of partitioning. What it is and how it will look, we will discuss later. In short, it divides our array in a certain way, and regarding the division, roughly speaking, by pivot elements, we will learn all about this a bit later. It will, you could say, then reassemble it in reverse order. Purpose. It is used in computer science programming for sorting data. The classic purpose, like all sorting algorithms, is to sort, working principle of the algorithm. Quicksort works as follows. First, a pivot element is chosen in a sequence of numbers. The second step is partitioning. All elements are divided into two subarrays. A subarray of elements greater than the pivot and a subarray of elements less than the pivot. Do it differently. Then repeat the first two steps on the subarrays. If the array has two or fewer elements, skip recursion. Why skip recursion for two or fewer elements? As a rule, if we take the pivot element there, then accordingly the second element will also become a pivot, and therefore they will already be, roughly speaking, sorted in their proper order. If this does not happen, then accordingly, if there are two elements and they are not sorted, then accordingly in this case we apply this algorithm. There are just several types. In our specific algorithm, specifically in our steps, we will use partitioning by the pivot element, where two elements are sorted to ensure they are in the correct order, so we don't have to check whether both the first and second elements are in the right order. But there are several types of this implementation, so this step is written here accordingly and this comment specifically applies to another type of sorting. I left this for the variability choice for our viewers accordingly. Step-by-step algorithm. So, the first step, we have an array of size 9 which consists of the following elements 38, 20, 0, 4, 5, 6, 3, 1. Here's another array, not like the ones in the previous sorts. I took one that's a bit larger so the numbers are quite different. So, what is happening here? We choose a pivot element, in this case it's 4, and using it we divide the array into elements greater and elements smaller. Here we choose 4 and see which elements are smaller or greater than 4. Smaller than 4 are 0, 3, 1, and greater than 4 are 5, 6, 20, 8, 30. This is how we divide the array into elements that are greater and elements that are smaller, which is less. Here are the greater elements, the lesser elements. What is greater? Here they are, 38, 25, and 6, and less, 0, 3, 1. They are not automatically sorted in any way. What happens next? After we have divided everything relative to the pivot element 4, we will do the same with the left part and do the same with the right part. Accordingly, here we will repeat these steps until we have the pivot element, meaning all elements of the array become pivots. Eventually, all elements of...
Want to become a great programmer? Subscribe to our Telegram channel.
So here is the second step. We divided the array and now, for example, we take the left subarray and the right subarray. For the left subarray, we take the pivot element, for example, 5. But in this case, it will actually be 20. The example just takes some element, but in reality, we always take the central element regardless of its value. So, greater than it will be 30, and less than it will be 5, 6, and 8. Thus, we get two more subarrays. If we divide everything relative to 0, 3, 1, we also choose the central element. Greater than it will be 0, 1, and less will be empty. We do the same with the array 8, 5, and 6, and the same with the array 0, 1. We choose the central element, and in this case, from two elements, the central or pivot element will be 0, and accordingly, 1 will be attached, and it will again attach this one as the pivot element, but since the size of the array will be single, accordingly, it will not produce anything more there, and so it gets 5, 6, and, accordingly, the fourth step, sorting is not needed for 30, sorting is not needed for an empty array. Well, 0 is less than 1, no sorting is needed. In this case, there is a check to see if the first element is less than the second or not. Here we won't have this check, so we will sort everything in the way that is needed. That is, we will indeed still suspend this matter. Accordingly, the fifth step, by combining the obtained subarrays and pivot elements, we get the sorted original subarray. How will it be assembled? He will first gather from the branch that is smaller on the right, and then from the branch that is larger, and move to the left. So there will be an arc like this. If you draw it as a tree, it will look like. This tree, it divided, and so on. Accordingly, the smallest will be on the right and the largest will be on the far left, and that's how it goes. It will gather them from right to left or left to right, and accordingly, a sorted array will be obtained.
Want to become a great programmer? Subscribe to our Telegram channel.